Then negative 6x plus 33 equals 3y. Negative 2x plus 11 equals y. Talk to me about what happens when we compare the properties of the line in each form of the equation. So what are the properties of a line? First of all, what are properties of anything? They're the stuff you can tell me about it, yes? So what is about the only stuff you can explain about a line? The slope and any points that are on the line, yes? So, what can you tell me about the blue slope?
They intersect on the same dot.
Well, that's telling me about both of them. I only want to know about the blue slope, but you're right. You're right. They do intersect. But what can you tell me about the blue line? What can you tell me about its properties? Okay, Aaron and Joseph just told us the only stuff you can tell me about a line. It's some of its coordinates and its slope. Now I am asking you to tell me about the blue line specifically here. What can you tell me about it? No, it does not have a y-intercept of 33.
Y-intercept of 11.
It has a y-intercept of 11.
X is a -2.
And a x-intercept, no, not an x of -2. A slope of -2. Excellent. What can you tell me about the red line?
This slope is 3/4.
It has a slope of -3/4
And
and y-intercept of 6. Each line by itself is very easy to explain the properties of each line, yes? But I do not want the properties of each line. What is this section called? Properties of systems. So what can you tell me about the system? Remember, a system is at a group of at least 2 equations, and automatically a group of at least 2 lines. Joseph. They have an intersection. So, the lines, I am in blue ink, a slope of -2 and a y-intercept of 11. And the red line was a slope of -3/4 and a y-intercept of 6. Each line as a system, which I'm going to write in purple, there's a solution at 4, 3. Does everybody understand? Why is there only one solution?
There's only 2.
Because they're straight lines they can only hit once. There is only one spot in the entirety of the universe where these 2 lines will cross. Right? Mm-hmm. Great. Do that exact same thing again. When you have finished graphing, tell me the properties of the blue line. And the red line. And then, what does that tell me about the system? Pardon me? They're parallel. How do you know they're parallel? And if they are parallel, what does that mean? They never intersect. So would there ever be any point in attempting to do elimination or substitution on this system? Why not, Joseph? They'll never intersect.
They have the same slope.
Because they have the same slope and a different y-intercept. Everybody understand? Excellent. Guess what? You're going to do it a third time. Turn the page over and do it again. This time, don't bother writing anything. There is that guy graphed, right? How did I graph him? Because the fractions scare us. I changed the scale. Agreed? This has different numbers. But what is it? What is it really? Same thing. Why? Because the fractions will simplify. And when should we simplify fractions? Every time we see them. Which means, if that is the red line, where will the blue line be?
The same.
Right on top of it. Meaning, how often do those two lines touch?
Always.
Infinitely. So, this one, we're just going to write in purple because they're the same line. Spelled wrong. They will intersect infinitely. How does this help us? When your systems get more complicated, you can run this check before you start trying to do substitution and elimination. Because if you find out that the lines or the curves that you were graphing are the exact same thing, then you don't need to bother with substitution and elimination. If you find that they are simply moved up or down, which if you were in grade 9 or 8 and you studied transformations, which is where you take a shape that you've drawn on a graph and just move it, if it has just been moved, there will have no connection. And of course, if they're totally different, there will be a solution before you bother doing all the algebra. Everybody understand? So, without solving these systems, so no substitution, no elimination, and no graphing, tell me if I should bother. So I need to know if there is a solution, there might be one, or there might be none, or there might be infinite. What tells us where these three options go? If there is one solution, what will the two lines share? They will share one intersection. So will they share a slope? Will they share a y-intercept? Possibly, because they could intersect at the y. If there is no solutions, what will they share? They will share a slope. If they are infinite solutions, what will they share? A slope and a y-intercept. The first two are very easy because they're already x and y. The third one becomes slightly more difficult. So what are you going to do with the first one? What are we looking for? We're not going to get rid of anything. We're going to isolate y because as soon as y is isolated, we know our slopes and our y-intercepts. So the first one, 2y equals negative x plus 6, y equals negative 1/2 x plus 3. Y equals negative x minus 2. Do they share a slope? No. As soon as you say they have different slopes, how many solutions will they have? 1. Because if they have different slopes, they have to cross somewhere in the universe. 1. Let's do B. Isolate y. What do they share?
Nothing.
Of course they do. I have written it out of order on purpose. What do they share? Slope and y-intercept. Because 9 over 5 is 18 over 10. So how many solutions? Infinite, because they're the exact same line sitting on top of each other. And lastly, obviously it's going to be the 0 one, but the reason this causes problems for you people is it's no longer x and y. So how do you find slope? Isolate either of the letters, and that one becomes your y. Doesn't matter which one you use. So negative 5q equals negative 2p plus 30. Q equals 2/5 p minus 6. This one, I've chosen to isolate q. Q's all ready to go there. Q equals 4/10 p minus 15 over 10. What do they share? Yes, they do. They share a slope because 4/10 is 2/5. But 6 is not 15 over 10. So they will have one solution. Does everyone understand? They will have 0 solutions. Sorry. Because they share slope. Just as I was going to say that, I looked at the red one. Are we all good? It's pretty simple. Different slopes, one solution. Same slope, no solutions. Same slope, same y-intercept, infinite solutions. It's the entirety of the lesson in one sentence. Does everybody understand why? Because the concept is simple. They're either going to cross, not touch, or be on top of each other. That's the whole concept. The important part of this is why that is the case. Is everybody good with why? All right. As always, there is some practice on it, but you will notice how little it is. I assume that you will be fine with that. Please turn the page over to 252. As I said earlier, the last lesson of the 10th grade. Word problems scare you. I do not know why word problems scare you. All of you can solve problems in real life where nobody gives you instructions. Word problems tell you exactly what you are looking for. Therefore, they should be very easy. In real life, nobody tells you how to solve your problems. Word problems tell you exactly how to solve your problems. So do not be scared of them. They're easy. Let us go about them. First thing I tell you to do is identify what you are looking for. That is absolutely key. You must identify what it is you are seeking in math, in English, in socials, in life. If you do not know what it is you seek, then how can you find it? And then you end up feeling, ugh. Okay? Same thing in math class. Now, the next part of that statement is something I borrowed from my grade 7 teacher. My grade 7 teacher wouldn't even mark our work if we didn't do the second part of this. We had to write it out by hand. So if I was in grade 7, I would have had to write, let x equal blah, 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 blah. So, I'm going to show you what I had to do in grade 7. Then I'm going to show you what I need you to do. And if you do at least what I need you to do, then you will never have a problem answering any word problem question ever. Okay? So, step 1 I told you was absolutely essential. What is it that I am seeking?
The sum of two numbers.
Read the question. What am I seeking? No, I am not seeking the sum of two numbers. I know the sum of two numbers is 176. I am seeking two numbers, yes? Therefore, there is two unknown things in my life right now. If I was in grade 7, I would have had to write this. Let x equal, do not write this down, the first number. And then I would have had to write let y equal the second number. And that's what my grade 7 worksheet would look like. That was 1987. This is 2018. Right. And I will be teaching you more stuff in 3 days. 3 days is going to be Saturday. I am perfectly happy if you do this. Yes, it will. Today doesn't count. Yes, Wednesday, Thursday, Friday. You're right.
4 days.
I am perfectly happy if you do this. Number 1 equals x. Number 2 equals y. If you do that for all of these 4 questions, it will take you literally 5 seconds to do each one. That is how simple it is when you actually write down what it is you seek. That is what you should write down. Now, write some equations. What do you know about these two numbers?
It's 176.
Their sum is 176. What math is sum? So number 1 plus number 2 must equal 176, right? So x plus y equals 176. What else do we know?
The difference is 40.
The difference, x minus y, equals 48. Now, a great many of you have been shown a little shortcut to solve these random unknown number questions. Almost all of you have seen a shortcut to solve these in grade 6, 7, and 8. The problem with that shortcut is it works wonderfully for these random number questions, but not much of anything else. So filling your brain with it, to me, seems a little silly. That's kind of like saying, here's a hammer. Go build a house. What? Well, I've given you a tool. You need tools to go build a house. Go build a house. You need some more tools to build the house. Same thing with math class. So I would rather show you a way that always works, no matter what, which is what I am doing now. What have I written right there? No.
X plus y equals 100.
Yes, that's what I have written. What do we call a group of two equations? I have written a system. Do I have the solution to that system? No, I must find the solution to that system. I've been given 3 methods: graphing, elimination, and substitution. It is set up right now perfectly for one of those three strategies. Which one? Elimination. Why is it set up perfectly for elimination? If I add them, what will happen to the y's? The y will disappear. Right? So let's do so. What is x plus x?
X plus
2x equals, what's 176 plus 48? 224. Right! Now what? Divide by 2. What's the answer? Tick, 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 tick. 112. Yes? Now, what do I get to do with that x? Any x I see, I can write it into. Are all the x's on the screen useful to me right now? No. Which is the x that I do not want to use? I got an x there in yellow. I got an x there in green. I got an x there in blue. Which is the one that is useless to me right now? The blue one. Because I already know x. I need to find y. So I am not going to use that x. I say this because when I say you can write the x anywhere you see an x, recently I have had some students putting the x back there. And that's a little frustrating to me, because I didn't think I would ever need to tell you not to put it there. But apparently I do. So, if I write it there, I would get 112 plus y equals 176. Is that yellow visible to you people? Good, because I'm keeping with the highlighter. Y will equal 64. If I wrote it here in green, it would be 112 minus y equaled 176. Minus y equaled, equals 48. 48. Minus y equaled negative 64. So y would equal 64. By doing algebra, Ariana, I subtracted 112 from both sides. I know I am starting to sound exasperated, but every time we do that equation, you ask me that. Every time. Please, please, please. It's always the same answer. I moved it to the other side. Okay. Is everybody good? Easy peasy lemon squeezy, correct? Now, if I was in grade 7 and I handed this in, my teacher would not have even marked it. Why? I haven't written a sentence answer, and word problems need a sentence answer. No, my grade 7 teacher was a British man. Yes, he is the hippopotamus man. Now, I am not like that, Because in the real world, when you solve a problem, you do not stop and write out a sentence answer and then go fix the problem. Oh my goodness, this man's heart has stopped. I should perform CPR. You do not find a notepad and write, this man's heart has stopped, therefore I should perform CPR. You just perform CPR. Same thing here. Number 1 equals 112. Number 2 equals 64. Done. Because this is math class, not writing sentences class. Okay?
Yes, sir.
Let us look at the next question, cabbages. What is unknown?
The price.
The price of a chocolate bar and the price of a pop. So, what should I do? Oh, you crazy man. That's some original variables.
Would it be 4x plus 3y equals 5?
C equals chocolate. You could, Ariana, but our good friend Zach has decided he is going with P and C. And that's fine. Could you go with X and Y? Could you go with Q and R? Could you go with lightning bolt and dollar sign? Could you go with the Sanskrit letter for sky and the Sanskrit letter for health? Yes. No, of course not. Neither do I. But it does not matter, does it? Could you use a red square and a blue square? Yes. Because it doesn't matter. So, what do I know about 4 chocolate bars and 3 pops?
They cost $5.30.
So 4 C's plus 3 P's equals $5.30. What do I know about 2 chocolate bars and 1 pop?
They cost $2.20.
2C plus P equals 220. Am I set up for elimination or substitution? Or neither right now? I am set up for neither, so I must perform some math to change what one of these equations looks like. I could multiply the bottom one by positive 2 and then subtract. I could multiply it by negative 2 and then add. I could multiply it by negative 3 and then subtract. Add. Or I could multiply it by positive 3 and then subtract. Or I could isolate P and do substitution. 5 options here. Is there any reason for you to look at it and say, oh, no, yeah. Of course not, because you are given 5 options. Now, personally, I would use substitution here because P is good to go, and I know as a grade 10 student, if I have to distribute, there's a chance I'm going to screw it up. Because I often forget to multiply all the terms. So I'm going to go ahead and use substitution here. You use what you like. Because if you do it right, and how will you know if you did it right? You will check it at the end. We will get the same answer, won't we? Let's. the other way around. I did the chocolate bar in pink and I wrote pop in pink, so I screwed that up. No matter what you did, if you did it right, and let's be honest, the only grade 10 part of this is deciding whether to use elimination or substitution. Otherwise, it's just grade 9 algebra, right? So you have a chocolate bar for 65 cents, which hasn't been the case for a long time, and pop for 90 cents, which you can still find at the dollar store. I don't know why anybody buys pop anywhere but the dollar store. 2 cans of Coke for $1, real Coke. Why do you go anywhere but the dollar store? I don't understand it. It makes no sense to me. There's dollar stores on every corner. Go to them. Yeah. Why would you pay more than that for the same thing? Well, because we're the same society that allows Coke to put Coke in littler cans and charge more for it. And we still buy it because we're idiots. It's not because we're idiots. It's because we are so used to stuffing our faces that we can't say no.
I went to a restaurant and to make it smaller, there was an extra $1.50 on top of the original price to make it smaller. I looked at that and I thought it was
I don't know what to tell you. All right. Everybody good? Now, of course, if chocolate bars were 65 cents, I would be in big trouble because I have a fondness for crunchies.
See,
I loves me a crunchy bar.
like crunch?
Crunchy. The chocolate bar crunchy.
Crunch.
No, not crispy crunch. Crunchy. The yellow, bubbly middle with the chocolate on the outside. The sponge toffee.
And the ones with
The ironic thing is when I was your people's age, I hated crunchies. They were the first thing I threw out of my Halloween bag. Then I threw out the Three Musketeers bars. I don't know why anybody gets a Three Musketeers bar. Nougat and chocolate. No caramel, no nuts, nothing. It's like a Mars bar without the caramel. It's gross. I don't know why anybody likes it. It's my second least favorite chocolate bar. Big Turk. Grossest chocolate bar ever made. Big Turk.
it's like Jell-O.
Big Turk is disgusting.
Damn.
It's gross. Yeah, what about them? You're crazy in the head. And the Reese's peanut butter cups that have Reese's Pieces stuffed in them as well? Oh. Yes, they do. You got, because that's hazelnut. That's not peanut. All right. You can still find decent prices on chocolate bars if you go to like Save on Foods. They always have chocolate bars for $1. Not even bulk. Right at the counter. There's always right down the checkout line.
Why do they call it a dollar store if some things are like $2? This makes sense.
Inflation. All right. Turn the page over. In number 3, what do I seek?
The startup fee.
I seek the startup fee. What are my 2 unknowns?
The monthly fee.
The start fee and the monthly fee. What letter shall we assign to the starting fee? Oh, you guys are so original. S. What letter should we assign to the monthly fee? M. Boring. After 1 month, I have paid $260. How many startup fees have I paid? 1. How many monthly fees have I paid? After 1 month, how many monthly fees have I paid? 1. And how much have I paid in total? 260. After 6 months, How many startup fees have I paid? 1. How many monthly fees? 6. And how much have I paid in total? 435. What am I set up to do right now? I'm set up to do elimination if I subtract, right? Now, go ahead and do that, but I'm going to show you something that you've seen once or twice that is going to be very useful to you next year. But I haven't actually taught it to you, really. Watch this. And you have seen this. Watch. Do you all agree that S equals 260 minus M? Do you all agree that S equals 435 minus 6M? So then you must agree that 260 minus M equals 435 minus 6M, yes? And that is an offshoot of elimination. See what I did there? I eliminated S by making both of them equal S and then making them both equal each other. Why do I do that? Because later on, systems get more complicated and this becomes a really useful tool. And the other reason I like to do it is, what did Joseph say we were going to do over here? He said we were going to subtract, yes? Which is super easy. S minus S, 1M minus 6Ms. But if this M were negative, a lot of you would forget to do minus minus. Understand? And then, of course, because you refuse to check your work, you would hand it in to me wrong. So I like using this sometimes as well, especially on complicated systems, or if I am deciding that subtraction might be in order. Okay? It's just another tool in your mathematical toolbox. All right? So let's go. What is M minus 6M? Negative 5M equals. What's 260 minus 435? Negative 225. What does M equal? How many times does 5 go into 225? It's 225 divided by 5. 45. So what is my monthly fee?
Isn't it $45?
If that is my monthly fee, what is my startup fee?
So you do 6 times 45.
Startup plus 45 equals 260. Startup equals 215.
What if you use the blue equation? It'd be the same thing.
Of course it would. Now, if I come over here and work this one, that M's going to go over there to become negative 5M. That's going to go over there to become 260 minus 435. And that's going to be 225.
Wouldn't it be negative?
Negative. And then we would get the same numbers. Does everybody understand? Now, what have you noticed about all 3 word problems? They're all exactly the same, aren't they? Talking about 2 random numbers. Talking about pop and chip prices. Or pop and chocolate bar price. Talking about startup fees and monthly fees. Yes, Marat. Yeah, I thought so. That seemed wrong. 175. So that makes that 35 And that makes that 225. You guys.
I screwed you guys all over again. That was intentional.
Oh, crap.
Yeah.
That was intentional. Yeah.
There we go.
Thank you. No problem.
35.
So, now that we're back to being able to add and subtract in the 10th grade,
45.
you have a calculator in front of you.
35.
Oh, I see. You're doing it. You're going old school. All right. So, back to the point I was making. What have you noticed about all three? They're exactly the same. No matter what words I put in there, there's two unknowns, and we use a system method to solve it, right? Okay. So let's look at number 4, because number 4 always scares people and everybody does it poorly. Do I have two unknowns? What are they?
How much did he invest in trade?
Right. So I have investment 1 and I have investment 2. Correct? So my next step, because everything is the same, is I give them variables. What do we want to give the first one? It doesn't even matter. Fine. Lightning bolt. Lightning bolt. Half a Christmas tree. And what would you like to do for the other investment?
A heart.
A heart. All right. What do I know about these two investments? Read the question. Talk to your neighbor if you need to.
He invested $2,000.
I invested $2,000 in total, yes?
Yeah.
So investment 1, lightning bolt, plus heart must equal what?
$2,000
2,000. What else do I know?
at 8% per year.
8%. One of them earned 8%. How do I write 8% as a number we can actually do some math with?
Decimal.
0.08. So, 0.08 lightning bolt plus, how do I write 10% as a number I can work with? 0.10 heart equals how much interest did I make? 190. Now, what is it about that system that makes you have a little bit of throw up in the back of your mouth? The decimals. The symbols are just X and Y.
If we wanted, we could just do X, Y.
Yes, of course you could just do X and Y. That's the whole point. How do I make that equation look like something I am comfortable with without changing my answer? Take away the decimals. How? Multiply. By what? 10? 100. Why 100, Aaron? Because there's 2 decimal places there. So if I multiply that by 100, what do I get now? 8 lightning bolts plus 10 hearts equals what?
190 times 100.
19,000. And now I can get rid of this guy because the decimals make us cry in our pants a little. Wait a minute. Cry in our pants. Pee in our pants or cry in our hankies.
Pee in our eyes.
Pee in our eyes and cry in our underwear.
Can I just erase this?
And now, am I set up for anything? I'm set up for substitution if I move one of these, or I'm set up for elimination if I multiply. Does it matter which you do? No, because you have to do some bit of algebra. I am going to go with this one. Lightning bolt equals 2,000 minus heart. So now I just come down here. 8
This is so messy.
times 2,000 minus heart plus 10 hearts equals 19,000. So now that I'm all hearts, 16,000 minus 8 heart. You can't draw a heart now?
It's so messy.
Zach, you can't.
Plus 10. That was a good one, Zach. Come on. That was funny. 16,000 plus 2 hearts equals 19,000. 2 hearts beaten in just one time. You guys don't know that song. Phil Collins, 2 hearts beating it just one time. Together forever till the end of time. Nothing. Phil Collins,
Just
yeah.
did 10 minus 8.
3,000. 1 heart is 1,500. Which means, if investment 2 is 1,500, what was investment 1?
So
500. Now, the question, though, says how much did I invest at each rate? Well, I made the lightning bolt 8%, and I made the heart 10%. So I invested 10%, 1,500 at 10%, 500 at 8%. Did it matter that I changed the words? Did it matter that I changed the scenario? No. Because I started the very first question with 2 random numbers, yes? What did we have here? 2 random numbers. It's the same math, no matter what we call it. So when you turn the page over and you see these giant paragraphs, what are you looking for? 2 random numbers. All of the rest of those words are there to scare you. Okay? Do not do this. 3.
Wait. Why are you using 3? Ew, that's scary looking.
Do not do 3 bears. Just use X or Y. Hey, have you guys seen that ad where it's a joke? Well, wait. They're shooting a washing machine commercial. And the washing machine is out in the middle of the snowbanks. And there are a bunch of people setting up the commercial. And then you hear, roar! And everyone looks off screen and goes, ah! And runs away.
Yeah.
And a bear walks into the middle of the commercial. And everyone's quiet. But they left the camera, right? Because they just want to get away from the bear. Then the bear stands up. It's a grizzly bear. He stands up and he goes, roar! And then he looks over at the washing machine. And he unzips. And he throws his fur into the washing machine. And then he pulls it out. And it's white. Because he's actually a polar bear. And his fur was just dirty. It's hilarious. It's like a Norwegian commercial. Yes, it is.